So what I do is I take tools from physics and I apply them to questions of biological importance. So I started off in graduate school making a magnetic polymer, and it's unique because it's the only flexible magnetic material of its kind. So we found all sorts of things that we can do with that. And then we discovered that we could use the same material, the same magnetic material, to make tiny little spheres. And we can use those spheres for all sorts of interesting biological applications. So we can, for example, put a chemotherapy drug inside the spheres because it absorbs really nicely into that material. And then we can use the magnetics to direct it to a certain location in the body, in principle, and then release it there at the site of a tumor using, again, magnetic fields to stimulate the drug release. So we get a really high dosage of the drug right there at the tumor and minimize the dosage everywhere else in the body. I've always been interested in how things work and kind of understanding the way that the universe is all put together. And then it was when I got to graduate school, the lab that I found there to get involved in was a lab that was working on biological questions. They were physicists, they were working in a physics department, but everything that they did had a biological focus. I'm interested in the practical outcomes, the applications of the science, but my primary motivation is my students. I mean, I'm a teacher first. That's what we do here at Elon, and that's why I came. So what really excites me is to get a new student involved in research and to begin to integrate them within the scientific community pretty much right away. So I tell my students that their career starts now. They're already working on developing their CV, on publishing papers and giving conference presentations, and doing research which will develop into a career path for them. One of the first things that we tried was to use the microspheres to specifically target cancer cells. So I had a biochemistry major who was working in my lab, and she was really interested in the biochemical applications of our work. And so she took a particular little chemical group, it was actually folic acid, and she bound it onto the surface of our spheres. And it turns out that a lot of cancer cells overexpress folate binding protein on their surface. So it's a protein that binds folate. And so now you introduce the spheres to a population of healthy cells and cancer cells, and they bind specifically, they target the cancerous cells and they stick on their surface. But what we're hoping to get out of these magnetic microspheres is progress along the lines of new cancer therapies or new drug delivery modalities. And so it's really turned into a fulfilling area to work. I'm always learning something new, and I'm always finding new people to collaborate with. So I've been working with people from the chemistry department, from the biology department, students from all the sciences here at Elon. And then I'm able to branch out beyond Elon as well to work with these biomedical engineering groups at our neighboring universities.